Alright, so we stopped here just now, and you guys are supposed to be doing the exercises for this. How to solve these problems. You can use formulas that we have learned before. Brakes are applied at the speed of the car is reduced. Determine the constant deceleration. Constant deceleration means constant acceleration. So if it's constant acceleration, you can use the formula lah. Formula 1, Formula 2, and also Formula 3. So work it out. A ball is thrown vertically upward at a speed of 15 meters per second. Determine the time of flight when it returns to its original position. Yeah, it is when it is thrown with an initial speed. Once it's thrown over, you have acceleration, which is 9.81. This one also you can do. Okay, next. So next is slightly different. It's something called erratic motion. Erratic motion is something that you see, for example, something like this. For example, this bike, initially at 0 until 10 seconds, the displacement is depicted like this. This is a mathematical curve. After 10 seconds, if you look at here, this is 0.3 t squared, right? So this is quadratic equation. After 10 seconds, the equation becomes linear. So this one becomes linear. So you have two types of motion. One part it is quadratic, the other part is linear. So you are combining two equations lah into the motion. Previously we learned only one, right? One. So now we learn two. So this is what we call by erratic motion. So when you have erratic motion, you can do a few things lah. For example, if you're plotting A versus T, and then this one you are plotting V versus T, and then for example this one you're plotting A versus S. So if you look at all these curves, it has area. So A kali dengan T. So area dia, ini paksi Y kan, this is Y axis, this is X axis. So the area under the curve is like this length multiplied by this length. So it's like A multiplied by T. So the area of the curve for AT punya graph, you're gonna get change in velocity. No. Area under AT graph, yeah, you're gonna get change in velocity. So area under the curve for VT, you're gonna get displacement. This is the one you look for. A dt, you're gonna get change in velocity. V dt, you're gonna get displacement. This one as, this is what you're getting. So don't worry, don't be confused. It's not so bad. Okay, look at this. So we've looked at it. There are two parts. So you have to analyze it properly lah, part by part. Just look at it analytically and solve it part by part. Solve part one first. So the equation becomes S as a function of time lah in this case. Sama dengan 0.3 t squared. So dia suruh cakap apa? Construct the VT and the AT graph. If you want to construct VT graph, you have to go back here lah. SVA. Differentiate differentiate. This one, integrate, integrate. Since you are here, right? Where are you? You are actually here, S. You wanna go to V. You definitely need to differentiate lah. So ds over dt sama dengan 0.6t. So this is the new graph. So 0.6t, you gotta plot into a new graph lah. Obviously, original the equation is quadratic, right? Quadratic. Now it has already become linear. So yeah. So now v equals 0.6t. In order to plot this one, plug in lah. V when time is equal to 0. So 0.6 multiplied by 0, definitely you're going to get 0 lah. So this is the original coordinate. So when time is equal to 10, 0.6 kali 10 dapat 6 meter per second. So this is where you add lah. So now you can plot the graph. The graph is V times T. Okay? Everything okay? So this is the first part lah. What is area under the graph? How can you describe this one? Area under the graph. Area under the graph for Vt. Change in velocity. Yeah. Change in velocity. No, this one is 80. Vt. This is the one lah. So you have just constructed this one. It was not this one, it was this one. So area under the graph is actually displacement. How do we know this? You can get from this lah. V sama dengan S over T. S is equal to Vt. This is the one lah. V multiplied by T. This is V axis, right? This is V. This is your T. Area under the graph, V kali T lah. So you can get displacement just by calculating what is the area under the graph. So next, if you differentiate this one more time, you do ds. This one is already V, right? You're going to get dv over dt is equal to 0.6. Differentiate one more time. So now you get a horizontal line. Okay. So you have to evaluate at two locations lah. 0.6. Wait. Let me see. 0.60. V is equivalent to 0.60. dv over dt sama dengan yeah, you get this 0.6. Oh, okay. Wrong. Remember? This is the thing that you should be looking for. You should not be looking at the original equation. This equation is only for the first part. This is already the second part. So for second part, we got to look at the second part. And you have to use the new equation lah. From 10 until 30, use the new equation. So the equation is S is equivalent to 60 tolak 30. So differentiate lah. ds over dt. Of course, we're still doing VT graph. So ini dapat apa? Dapat 6 terus lah. Betul lah. Dapat 6. So this is how you plot VT graph. Next, acceleration. Differentiate this one more time. This one becomes acceleration lah. We did this one just now. Jadi dapat 0.6. This is 0.6. And this part. Ini ds over dt dapat 6 kan? So meaning v is equal to 6. Put one more time. dv over dt sama dengan 0. That's why you get 0. You are differentiating twice to get acceleration. So it's pretty much the same like the one that we did before lah, which was this one, which was I think which was this one. Yeah, it's almost the same as this one. Only this one, the motion is continuous lah. Throughout the motion, only one equation. Now you have graphs, and throughout the motion, you have a couple of equations. From 0 to 10, this equation. From 10 until 30 becomes this equation. This is how you do it lah. Next, this is another example. Let's look at it. Blah blah blah. It's given this one already. I think you can read this on your own lah. We'll continue. You can read this on your own. Erratic motion. So next thing is something called curvilinear motion. So curvilinear, there is something called when you are moving at a curve. This is a curve. When you are taking a curve, if you are traveling even at constant speed, there is something called A normal. A normal, this is your A tangential, and then you're going to get A magnitude. So A normal is the normal component of the acceleration. This is always directed towards the center of the curvature. So this is the formula for A normal. So it is almost similar. In fact, it is similar to something called centrifugal punya acceleration component. So so A normal is equivalent to velocity squared over rho. This rho stands for radius. So for this one, I think I need a new screen. Let's get a white screen. So let's say you have a circle. This is a road. This is a road. It's going like that. What is this? This is a roundabout. Roundabout. So this is a motorcycle. This is a motorcycle. This is the rider on the motorcycle. So this motorcycle, it's traveling very, very fast. Berapa velocity dia? Let's say he's traveling at 120 km per hour. Very fast. So as it comes to a roundabout, it will make this curvature. So let's say the motorcycle has come to this curvature right over here. So it travels from here right to over here. It makes the turn, and then it gets here. So kalau dia bawa very fast, 120 km, there's a very big chance and possibility that this motorcycle akan terbabas. So kalau dia terbabas, dia akan terbabas arah mana? Naik atas ataupun turun bawah? Definitely 120 km per hour at a roundabout. And he is not even a racing driver. He doesn't have the skills. So definitely dia akan terbabas naik atas. Naik atas. Why is it so? Kenapa dia terbabas? Because of something called, whenever you move along a curvature, you're going to see something called A normal. A normal is the acceleration towards the radius of the curvature. Kalau A normal ada ke dalam ni, formula untuk A normal adalah V squared bagi dengan radius. So boleh check lah. Katalah radius dia, radius sama dengan, let's say, 25 meter. Velocity dia berapa? 120 km/h, tukarlah. 120 divide by 3.6 dapat 120 bahagi 3.6, 33.33. He is travelling at 33.3 meter per second. So 33.3 squared bahagi dengan radius 25 meter. This is the value of A normal. Squared bahagi 25. So 44.4 meter per second squared. This is A normal. So when you have acceleration, if you still remember, summation of forces is equal to MA. F sama dengan MA. So kalau F normal sama dengan MA normal. So nampak tak? A sebelah kanan, F sebelah kiri. So kalau A turun bawah, F akan naik atas. This is something called F normal or centrifugal. So that's why this motorcycle, walaupun dia travel dengan constant speed, dia still ada acceleration normal. It is something like a centrifugal force. So that's why this motorcycle will be going out that way. Or if you look at fan blades. Fan blades. Katalah one day there's a terrible mishap, fan blade ni patah. Definitely fan blade akan throw out macam tu. It's like that lah. Due to centrifugal force. So this is what we are learning right now lah. Yeah, this one, A normal. So let's look at the components. So whenever you are traveling at a curvature, you have A normal, no matter what your speed is. Tapi kalau constant speed, A tangential ni jadi 0 lah. Okay, so constant speed, A tangential is 0. A tangential is your acceleration. This is your acceleration. The acceleration that you can manually calculate lah. This one is coming from what we have learned before lah. V2 minus V1 over time. Ini kan A. A adalah change in velocity. Ataupun kita tulis macam ni kan. V is equal to V0 plus AT. Betul tak? So V tolak V0 over time dapat A. This is the thing lah. That is your A tangential. This one. A tangential. This is A tangential. A tangential. A tangential. There. If the curvature, look at this curvature. This curvature go up, A normal turun bawah. And then when the curvature go down, A normal naik atas. Depending on the radius of the curvature. This is the tangential acceleration. So far what we have been learning is actually tangential acceleration. Kalau nak cari total A, you have to find the magnitude lah. AT squared, AN squared, square root. So this is curvilinear motion. Keep belah. So next part on the lecture is something called projectile motion. So projectile motion falls under the category of curvilinear. So you have linear, linear, linear. You have curvilinear, curvilinear. So curvilinear. So projectile falls under this category. So when an object is moving in a projectile motion, so it can be treated as two rectilinear motions, which is one in horizontal direction. So it is traveling in a horizontal direction, experiencing zero acceleration, which is no acceleration. Why? Because it's moving horizontally. Gravity is affecting us vertically. So another part is the vertical direction, which is experiencing constant deceleration, which is coming from the gravity. So if you take this tennis ball, one tennis ball is being propelled forward. So this tennis ball at time 1, let's say time 1, it is this location. Time 2, this location, similar height. Time 3, similar height. Time 4, similar height. Time 5 also similar height. So one object is moving forward. Another object is just dropping. So the rate of drop is the same for both objects. The rate of drop is same. So when you typically, if you want to incite projectile motion, typically you have to give a velocity at an angle, or you can just stand on an edge and then you just give a forward velocity. This thing will be dropping down like that. So now let's take a look at the mathematics behind projectile motion. So there are two axes. One is x-axis, another one is y-axis. So you need to consider two things lah. Number one, you need to consider horizontal motion. So consider horizontal motion. So for horizontal motion, since the motion in horizontal, there is no acceleration. Acceleration in the horizontal direction is equal to 0. Nothing. For example, if you put a ball and then you put a simple rocket at the back, this is different already lah. It has acceleration. But no, right? You just throw the ball or you kick the ball. You give it a forward initial velocity. This ball travels and then it just keeps on dropping. Then it's a different story, yeah. So for horizontal motion, we are still using back the same three equation. Equation number 1, equation number 2, and equation number 3. So for equation number 1, since there is no acceleration, you only left with this thing, which is Vx, V horizontal, is equivalent to, this is wrong, this is not S, not X, that's why it looks very weird. This is supposed to be V. Vx is equal to, like this, right? V is equal to V naught plus AT. So I'll modify this one. We need to modify this one. So it is actually This one, no acceleration. So v is equal to v naught, meaning final v naught x, yeah, meaning v is equal to v naught x. That's the thing. Original velocity is equivalent to final velocity, meaning if the linear velocity is 10 meter per second, final velocity linear is also 10 meter per second. So look at equation number 2. Sx is equivalent to s naught x plus v naught xt. Yeah, so this is correct. No acceleration. You are left with only this one. Sx is equal to s naught x plus v naught xt. You are left out with this one. So if you look at first equation, there's nothing much you can do with this one. V is equal to v naught x. Okay. But you cannot solve anything. Equation number 2, yes. This one is good. This one, no good. Equation number 3, if you cancel out this one gone. Vx squared is equal to v naught x squared. Nothing you can do with this. No, nothing that you can input to it. Only thing which is important, which is this one. Equation number 2. Number 2 is good. However, different story you're going to see if you look at vertical motion. Since you have gravity, so equation number 1 also very important. Equation number 2 is very important also, and equation number 3 is very important. So for horizontal motion, only one equation is good. For vertical motion, all equations are good. Only thing that you need to substitute is the A. A is equivalent to negative 9.81 meter per second squared. So this is the plot of the motion. So all your objects is going to have two components. Horizontal Vx, vertical Vy. This is the magnitude of the velocity. So same story. At the maximum and the highest point, it will have Vy is equal to 0. There is no vertical velocity. But horizontal velocity sama je. Vx, all the same. How about Vy? Vy keeps on getting smaller and smaller. For example, if Vy original is like this, as it gets higher, it becomes shorter and shorter until 0. This one becomes shorter. This one becomes 0 already, no Vy. But Vx, all same. Same length. Why same? Look at this formula. Vx is equal to Vx. Vx is equal to Vx. So by right, linear velocity, which is in the horizontal direction, remains the same. So once it goes like this, and then it starts to drop, and then Vy will have some value. Horizontal still Vx. Vy will have some value. Vy will be getting higher and higher and higher. So this is motion of a projectile. So now we can do some exercise on motion of projectile. So let's take a look at this exercise. A sack slides off the ramp with a horizontal velocity of 12 meter per second. Dia turun ni dan dia pergi depan. Velocity 12 meter per second. 12 meter per second. Remember, horizontal only. It has a horizontal velocity. If the height of the ramp is 6 meter from the floor, determine the time needed for the sack to strike the floor and the range R where the sack begins to pile up. Okay, so initial velocity. So let's look at the equation. Remember, you need to analyze two things. Probably need to do some cleaning up. You need to analyze two things, which is horizontal and vertical. Firstly, you analyze horizontal motion first. Analyze this one first. And you know already. This one, okay, this is wrong. It's actually Vx. This one is useless. Pretty much useless. This one is also pretty much useless. You only have one good thing, which is this one. So horizontal, only one good thing. Vertical, everything is good. Equation 1 good, equation 2 good, equation 3 good. For horizontal, only equation 2 which is good. So look at this. This will cari apa? Determine the time needed for the sac to strike the floor in the range R. Okay, so apparently we have Vx sama dengan, it's not actually Vx lah. It's actually V naught x, original velocity, 12 meter per second. V naught y is equal to 0 actually. Dia tak ada macam tu. Dia tidak ada Vy. Why? Because it's only horizontal. Unless it drops like this lah. Let's say it drops like that. Katalah dia drop 15 meter per second. Then this one you have to resolve into two components lah. Resolve x, resolve y. Then in this case you have two components. But however, in this initial problem, there is no component for y, only x, which is this one. Y is equal to 0. So let's write it down. Horizontal. Only equation 2 which is good. Equation 2 saja yang bagus. Equation 2 apa dia? S is equal to S naught plus V naught T plus half A T squared. Remember, acceleration is equal to 0. So this one is gone. Only good thing is this one. If you don't want to be confused, you might want to put x. This one is x. V naught x also. This thing is gone. Might as well delete it. Delete. Only this one is making sense. So Sx is this one lah. This is your Sx. This is your Sx. Displacement horizontal. This is your Sy actually. Displacement vertical. This is what we're trying to do. R maksudnya dia suruh cari Sx. Lepas tu time. So cari time berapa? Cari Sx berapa? Those are the two things that you need to find lah. So let's try to solve this one. Sx. So S naught x, original displacement x. Berapa? 0. Plus V naught x. This is V naught x. 12. T berapa? Tak tahu. So you need to find that T. So equation horizontal, the good thing that you can use is only one equation lah, which is Sx is equivalent to 12t. Now, let's look at vertical. So vertical, you can solve a lot of things, right? Equation yang berguna, equation 1, equation 2, equation 3. 3 equation you can use. But which one should you use? Look at the vertical. You have Sy. So you need to look at Sy lah. Sy is equal to S naught Y plus V naught Y T. Is this telling you something? Displacement Y, you know already, 6 meter. Is this thing correct? Macam tak betul je ni. Plus. Let's take a look back this equation. First equation, V is equal to V naught plus AT. Second equation, S is equal to S naught plus V naught T plus half AT squared. Third equation, V squared is equal to V naught squared plus half AT squared. These are the three equations, right? Now you can choose properly. Equation number 1, can you do anything about it? Equation number 1, do you have any information on equation number 1? We know that original velocity is 0. No. Yeah, correct. But we don't know Vy. Tahu tak? Ini semua Y lah. All Y. All is Y. I don't think it's very useful lah, this one. The thing which is useful is probably equation number 2 or equation number 3. Okay. You have Sx, you need to find the time. If you can find the time, then you're good to go. Most likely, I guess, this one also can. You can use the first one and second one. Let's try lah. There's no way to make sure anything. You just have to try. Let's try equation number 2, which is this equation. Sy, final. So final, they akan drop on the floor. So finally, it will become 0. Which equation are we looking at? We are looking at this one, We are looking at this one, this equation. Finally, it will drop on the floor. So final displacement is 0. Original displacement, it is high above. So 6 meter. Velocity Y, 0 kan? You don't have any vertical velocity. 0. Time pun 0 lah. So plus setengah, negative 9.81 T squared. Yeah, by looking at this, you can solve time. So what is the time that you are looking at right now? Solve it. 9.81 divided by 2. Berapa? 9.81 bahagi 2. 4.905. So you're going to get something like 4.905 T squared is equal to 6. So T is going to be equal 6 bahagi 4.905 punca kuasa 2. So time sama dengan 6 bahagi answer square root 1.106 second. So this is the time required for the sack. Sack ni apa? Kampit. To drop on the floor. So now you can plug in this time to here. So you're going to get Sx is equivalent to 12 kali 1.106. So what you get times 12, 13.27 meter. Have we answered everything? Dia suruh cari apa? Dia suruh cari time dengan time dah dapat, Sx pun dah dapat. Now you can check. 13.27 betul, time 1.11 betul. So Yeah, you can look at the solution, or you can look at this example on how to do it. So next, let's try another one. This one is apparently it's called a chipping machine. Chipping machine. It's designed to eject wood at a speed 7.5. It's given you V naught, so this is the original velocity. If the tube is oriented at 30 degrees from the horizontal, determine how high the chips strike the pile if they land on the pile 6 meters from the tube. Okay, you guys understand this one? Chipping machine is designed to eject wood at 7.5. If the tube is oriented at 30 degrees from the horizontal, determine how high H. Okay. If they land on the pile 6 meters from the tube. Okay. So they fix this one lah. 6 meter is fixed. This is your SX. Dia suruh cari ni lah. This is the datum. Dia suruh cari SY. That's it lah. That is what it is trying to cater lah. I know this thing will, in the initial stage, it will fly out and it will land somewhere probably here. I know. But at this location, where, and so this is the top. Where is it? Okay. It corresponds to 6 meter. This is already 2.1. So 2.1 stands for S not Y. This is final displacement in the Y direction. This is SX lah. Okay, so I guess that's it lah. So if you have something at an angle like this is an angle, you better solve the angle first. Let's solve it. So Vx sama dengan 7.5. This is 30 degrees. This will be your V naught x. This will be your V naught y. So it's actually not Vx lah, it's actually V naught x. 7.5 cos 30 degrees. Berapa? 7.5 cos 30 degrees. 6.495. So close, huh? I'm taking it as 6.5 meter per second. V naught y. 7.5 sine 30 degrees. Berapa? 7.5 sine 30. 3.75 meter per second. So these are the two important things. So apa nak pakai ni? What are you going to do? Obviously, mula-mula settle horizontal dulu. Horizontal yang penting equation number 2 je. Equation number 1 apa? Kena tulis lah. V is equal to V naught plus AT. Equation number 2. S is equal to S naught plus V naught T plus half AT squared. Equation number 3. V squared is equal to V naught squared plus 2A S minus S naught. So these are the equation. So in horizontal direction, only equation number 2 is very important. So just settle equation number 2 lah. Remember, S x S naught x plus V naught x t. This is it. Why no acceleration? Ini tak ada untuk horizontal only. Okay, tak ada untuk horizontal. This one not applicable for horizontal motion. Ini saja yang berguna for horizontal motion. Okay, horizontal motion. So let's take a look. Sx dah ada value kan? Sx 6 meter. S not x 0 lah. V not x. There you go. 6.5 t. Dapat terus time. Did we just solve the time? I guess so. So time dapat 6 divided by 6.5. 6 bahagi 6.5. 0.923. 0.923 second. This is the time. Okay, so now we are solving vertical. Vertical. Equation 1 pakai, equation 2 pakai, equation 3 pun pakai. So, we got to remove this one. Which one is good? You have to look at the things that you have information of. Do you have the information on SY? No. But I guess you can just plug it in. Why is this seem so easy? Let's try. Let's try. So we're going to be using equation number 2 lah, I suppose. Sy S naught y plus V naught y t plus half at squared. S naught y Sy tak tahu. S naught y original height 2.1. V naught y, this is the one lah. This is V naught y 3.75. Time dah dapat 0.923 plus half negative 9.81. Why is this so easy? 0.923 squared. So berapa? 2.1 plus 3.75 kali 0.923. 3.46. 46 minus 0.923 squared kali 9.81 kali 0.5. Remember, this is a negative, so 4.18. So campur, tolak 2.1 campur 3.46 tolak 4.18. 1.38 meter. 1.38 meter. This is your SY. Betul ke tak? Let's check it out. 1.38 meter. Ya, betul lah. Pretty easy, right? Seems like the most important equation that you have been using is equation number 2 lah, for both cases, apparently, because it has all these things. It has time. Equation number 3, no time. Equation number 1, no displacement. So yang paling lengkap inilah equation number 2. Okay, next. Next equation is this one. The rider jumps off the slope at 30 degrees from a height of 1 meter. The rider remained mid-air for 1.5 seconds. Determine the speed at which he was travelling off the slope. the horizontal distance he travels before striking the ground. I suppose you should be doing this on your own lah. Try to solve this on your own first.